Okay, in this lesson, we're going to begin talking about a new type graphing system called the polar coordinate system. Okay, up until now, it says you have graphed on a rectangular plane containing an x and y axis. We will now look at another system called the polar coordinate system. To form a polar coordinate system, we're going to fix a point called the pole, or another name for that is what we've been referring to as an origin. That's the beginning point. From that point O, which we can see here in our diagram over here, from that point O, we're going to construct an initial ray, and we're going to call this the polar axis. And again, you see a lot of similarities to what we did when we were graphing angles, to where the positive x-axis was kind of like what we were referring to here as the polar axis. And you can see the polar axis here. And then from each point P in the plane is assigned a polar coordinate. Now notice it's not an x and a y now. It's an r and a theta. R is going to be the directed distance from O to P. So we're going to start at O. We're going to go on our polar axis out a distance of P, or R. And then theta is going to be the counterclockwise directed angle formed by the polar axis and OP. So we're going to go out a distance of R, and then we're going to rotate from there an angle of theta. So instead of going over X and up Y, we're going out R and we're rotating an angle. Okay, it says when R is negative, we're going to graph the point, instead of r theta, we're going to graph the point r comma theta plus pi. We're going to pretty much add a 180 degree angle to it, or you can just do a negative direction on your r. Either one will work. Okay, so let's start plotting some of these points. Concentric circles are frequently shown. This is an example kind of what a polar type graph would look like, and it gives us these radii. You notice the radius here of 1, the radius here of 2, and the radius of 3, and then the angles of 30 and 60 and 90 and so on and so forth. So to plot the point A, which has a radius of 2 and an angle of 7 pi over 6, you simply go out 2 to here, and then you're going to rotate on this concentric circle. You're going to go rotate around 7 pi over 6 until you get to here. So we're going to, again, go to 7 pi over 6 on our angle. We're going to 2 on our radius, and that would be point A. Point B says to rotate or go out a radius of 0.5 and rotate 135 degrees. So 0.5 is our radius, which is about here, and we're going to rotate around until we find 135 degrees, which I believe is right there. So that would be point B. So we went 40 or 90 degrees and then another 45, and that would be correct. C says you have a radius of 3 and an angle of negative 60. So we're going to go out 3 on our radius, which is out here, and a negative 60 on our angle. And that's the same thing as going a positive 300 in the other direction, and that would end up right here. Again, each of these tick marks, I believe, are counting 15 degrees, so you have 30 degrees, and then 60 degrees would be there. D says you have a radius of negative 1. Now, I like to just do it like this. I like to notice that all my angles are rotated in this direction. I like to just go in a negative 1 direction on my radius, which would carry me to over here, and then rotate down 45 degrees, which would be right here. Now, the way that they told you to do it, and it's perfectly legal, you can use a positive 1 for the radius, and then just rotate an extra 180 degrees, which would carry you here, and then go another pi over 4, which carries you to the exact same place there. Number 5, negative 2.5 is our radius, and 4 pi over 3, that's 240 degrees. So we're going negative 2.5, which carries me to here, and then we're rotating 4 pi over 3, which is, again, what is that, 240, we say? So 180 would carry you back around to here, so another 30, 60 would carry you to there. And I believe that would be the 240, and that would be point E. And then finally, let me erase some of this stuff, this extra dots that I'm getting on here. Finally, number 6, point F, we have a radius of -3. So that carries me to here. Again, I just go in the negative direction. And then we're going to rotate a negative. Now, notice that every other angle, a positive direction would be this direction. So if I'm going to rotate a negative direction, -30 degrees, I'm going to go this way, and I'm going to end up right there. And that would be your point F. And I do notice, I can't remember, but I believe I went the wrong radius on B right there. That B should have ended up, I believe, right there instead. Naming polar coordinates. While each pair of polar coordinate plots a unique point, each point does not have a unique coordinate, and you might have seen that in the previous examples because different angles, again, we know coterminal angles will end up in the same place. In general, a point with polar coordinates r theta can also represented by r, comma, theta plus 2 pi n, or 2n pi. You can write that either way, which would be an angle plus, again, this would be just an extra rotation, or if it's negative, subtract a rotation. So you can add rotations on and you're going to end up in the same place. Or negative r, comma, theta plus 2n plus 1 pi. So that's pretty much just telling you that sometimes we might end up in the same place by adding on, like this would be half. That would be like a half rotation. Like if you're going in the negative direction, you could add on those half rotations by going in the positive direction instead. So just those points would lie in the same place is what it's saying. So here, name 3 different pairs of polar coordinates that also name the point. And let's try to stay between a -2 pi and a +2 pi on our angle. So one way we can do this, again, we can simply add on rotations. Now, rotations, that 2 pi, the common denominator, that would be 3, so that'd be 6 pi over 3 is what we're adding. So we could just take, and that point would be the same thing as 2, add a rotation of 5 pi over 3, and you get 11 pi over 3. Those would be coterminal angles is what we described them as. Or we could, from the original, we could took a rotation away from that and ended up in -pi over 3. So there's 2 different points that ends up in the same place. Now let's do one more. And the way we're going to do it is instead of going in the positive direction, we could go in the negative direction and then take away a half a rotation. Now a half a rotation would be, whoops, let's try that again. A half a rotation, which would be pi, which would be just 3 pi over 3. Because again, if we go out 2 and rotate up 5 pi over 3, well, that'd be the same thing as going out a -2, then add a rotation plus that additional on. So we could do -2 and then like 8 pi over 3 when you add that on, or you could go -2 and then subtract off that 3 pi over 3, and that leaves you with 2 pi over 3. So all of those would be the exact same thing. Number 8, let's do it again. The full rotation here, 2 pi, that we're going to add on is the same thing. Common denominator would be 8 pi over 4. So this point in your polar coordinate plane would be -5 and then add on a rotation, which gives you pi over 4. They end up in the same place. Or again, you could subtract off a rotation, and that would be the same thing as -5 and -15 pi over 4. Both of those would be identical. I believe that would be, let's see, that falls outside of the range. So instead of doing that, you could have added another rotation. That'd be 9 pi over 4, which I think might actually, again, fall outside of that range. Or again, your other options here is you could go in the other direction. Instead of doing a -5, you could go in a +5 radius direction and then add a half rotation onto your angle, which would be pi, which is the same thing as 4 pi over 4. So let's go in the positive direction instead of -5. Let's do positive 5 and add on 4 pi over 4, which gives you negative 3 pi over 4. Or you could go in the positive direction and add on yet another rotation. Erase that. That should be 5, comma. Add on another 4 pi over 4, and that brings you up to pi over 4. Actually, it doesn't. We would have to do a couple of half rotations from there, and that would be 5 pi over 4. And and you can check those out. Those points actually lie in the exact same place. The next one, a full rotation to get coterminal angles would be a 12 pi over 6. So let's take this and we could add a rotation on, which actually falls outside of that 2 pi. So let's take off a rotation and you get negative 1.5, comma, negative 11 pi over 6 would fall in the exact same place. Or instead of doing a negative 1.5 radius, you could do a positive 1.5 radius and add a half rotation on, which would be 6 pi over 6. So you could add on or subtract from, which gives you a 7 pi over 6 or a negative 5 pi over 6. And again, both of those points would lie in the exact same place as the original. Now, there is a distance formula when we're dealing with polar coordinates, and it's not near as easy as the distance formula we've done with rectangular coordinates. It's not near as simple. If you have P1 and P2 are points on this coordinate plane, then the distance between P1 and P2 is given by the following formula. And you see R1 squared plus R2 squared minus 2 times R1 times R, that should be R2 subscript, times the cosine of theta 2 minus theta 1. I don't know if you noticed this, but it looks a lot like that law of cosines, and there is a connection there. So let's find the distance between each of these pairs of points. So our distance will equal, again, we're going to do R1 squared plus R2 squared is our first part, minus 2 times R1 times R2 times the cosine of theta 2 minus theta 1. So we've got to subtract these two angles. So we've got 7 pi over 4. Let's go ahead and do a common denominator as we write it down. Multiply top and bottom by 3. Gives you 21 pi over 12. Minus, multiply top and bottom by 4. Gives you 4 pi over 12. 21 minus 4 gives you 17 pi over 12. Then the rest of that on out is just calculator work. You should get a distance of about 4.01. The next one, let's do it again. The distance is equal to the square root of R1 squared, which would be 1, plus R2 squared, which would be 25, minus 2 times R1 times R2 times the cosine of theta 2 minus theta 1. So let's go ahead and do that. 4 pi over 6 minus 11 pi over 6 gives me a negative 7 pi over 6. And again, the rest of it is calculator work, and you're going to get about 4.16. And again, just a reminder, here's your formula one more time if you need to write it down. It is R1 squared plus R2 squared minus 2 times R1 times R2 times the cosine of theta 2 minus theta 1. So in this one, we have the square root of R1 squared. Here's R1 to be 64 plus square root of negative 2 would be 4 minus 2 times 8 times negative 2 times the cosine of theta 2 minus theta 1. That'd be 310, and it doesn't matter it's in radians or degrees because you're just subtracting them anyway. That's 310 minus negative 175, which would be 310 plus 175, which gives you 485 degrees. Type all of that in, and you're going to get approximately 7.05. Number 13, the position of two ships around the iceberg. And now see, Now we're dealing more, if you think about the way that the Earth is set up, you have a lot of R's and thetas when you're talking about latitude and longitude. The position of two ships around an iceberg can be represented by the coordinates 12, comma 40 degrees and 28, comma 215, where the directed distance is measured in miles. Find the distance between the two ships. Again, the distance is equal to the square root of R1 squared plus R2 squared, and that's be 28 squared, which is 784, minus 2 times R1 times R2 times the cosine of theta 2 minus theta 1, that'd be 215 minus 40, which is 175. Type into your calculator and you're going to get right at 39.97, and it says we're measuring it in miles.